Hi guys, in this video we are going to discuss the problem Decode XORed Permutation, which is from Leetcode. So the problem statement states that we are given an encoded array of size n and the n is always even. So this encoded array is generated using this formula, which is encoded of I is equal to perm of I XOR perm of I plus 1, and it is said that the perm array is always odd in size. So you'll have odd size for perm, and the perm has first n plus 1 natural numbers. That means for example, let's say you have n equal to 2. This is the size of encoded array, so the size of the perm is going to be n plus 1, which is 3, and the elements are going to be either 1 comma 2 comma 3 or 3 comma 1 comma 2 or 2 comma 1 comma 3 or 1 comma 3 comma 2 and so on. All the permutations, it could be any of these. So that is going to be our perm array, but the elements are going to be the first n plus 1 natural numbers, right? So at last we are supposed to find the perm array. We are given encoded array, but we are supposed to find the perm array. So for better understanding, let's take an example. So here we are given encoded as 3. This is 2. Okay, we are given encoded 3 and 2. So how this goes, see, this is I am taking for just understanding purpose. This is not given. Okay, so here the 3 is generated by performing XOR operation on 2 and 1. That is 2 XOR 1 gives you 3, and this 2 is generated by performing XOR operation on 1 and 3. So that is how we are going to get this encoded array. So our task is to find the perm, not the encoded. Encoded is already given. Now this becomes tricky because you're given an output actually, but you're supposed to find the input and you don't know the order of the input. So let's see how we can solve this problem. And remember that encoded size is always even and perm is always odd. Let's quickly move on to the solution. So we are given this formula that encoded of I is equals to perm I XOR perm I plus 1. So I like to make small changes to this formula to get the desired results. So what I'm going to do is I'm going to replace I with I minus 1. So this becomes encoded I minus 1 perm of I minus 1 XOR perm I, right? And now I'm going to perform XOR perm I minus 1 on both the sides. So now this is going to be like perm I minus 1 XOR en, that is encoded I minus 1. So when you do perm, like you have perm I minus 1 and perm I minus 1, they both get cancelled, so you'll be having only this one. So this is going to be perm I. Okay, I hope you know the basics of XOR. So please do check the basics of XOR before watching this video. So the end result, the end formula that I wanted you to show is this formula, which is perm I is equals to en I minus 1 XOR perm I minus 1. So using this formula you can get the perm array actually. The problem is that you have the encoded array, so you'll get the values for this, but the problem is you don't know the values perm of I minus 1. So for example, let's say let's take I equal to 1. So the perm of I, that means 1 en, it is going to be 0 XOR p of 0. You know this value, you don't know this value. So only if you know this value you can proceed further. So this is going to be the entry point for the solution. You have to find the first element of the perm array, first element of perm. So when you know the first element of 1, it becomes easy for you to find the other elements. For example, p equal to 2, it will be en of 1. Use the formula p of 1. So from the above statement you can get the p of 1. So you can apply directly, then you can get p of 2 and p of 3 and so on. So the entry point is that you have to find P of 0. That is the first element of perm. I hope you understood how I arrived at this formula and how I'm going to start with P of 0. That means the first element. So let's see what we can do to find the P of 0. So I'm following these two steps to get the first element. The first element is the first thing is that you are supposed to find XOR of all perm elements. So how do we find that? Because you do not have perm elements, right? You do not have perm array. But in the question it is said that it is the n plus 1 natural numbers, right? The perm array is the n plus 1 natural numbers where n is the encoded size. So let's understand this approach by taking an example. So let's take n equal to 4 and en encoded is 6543. This example is already given in Leetcode. I'm just elaborating it. So what are we supposed to do? We are supposed to find XOR of all perm elements. We do not know the perm elements, but we do know that the elements are going to be the n plus 1 natural numbers where n is the encoded size, right? So here the size is n4, so we need first 5 natural numbers. Okay, what are those? 1, 2, 3, 4, 5. To find XOR you do not need the order, so you can find even if the order is different, right? So this is the first thing we are going to store, XOR all. So that is going to be 1 XOR 3, 4 and 5, right? This is the first step to find the first element of perm. Like you do not know the order, right? So only if you know the order you can find the first element. Like the one could be anywhere in this perm array, right? So to find that first element we have to perform these steps. And the second is going to be find the XOR of all except 1. We are supposed to leave the assume that the perm is going to be XYZ AB. The size is 5, right? This is perm. So we are supposed to find the XOR of the last 4 elements, leaving the first one in order to get the first element. But how do we do that? We do not know the elements. It could be any of these 5 elements in the 4 elements, right? How do we do that? We can find this XOR using the encoded array, because see, encoded is generated like this, right? XY, YZ, ZA and AB, right? So this one leads to this, right? So how do we find the XOR of all except the first one? So what we are going to do is we are going to start from this point in the encoded array and we are going to perform XOR on the alternate elements. Like leaving this one, I'm going to perform XOR on this element, like this one. Like if the size is more than, let's take you have 10 elements in encoded, then you'll get C, D, D, E. My next XOR will be on this one, just leaving the next one. I'm going to perform on this one. So I'm going to perform the XOR on the alternate encoded elements starting from this point. That means the first one index. So you'll get this one, like see, XOR except 1 equal to YZ and AB, right? So indirectly you are getting this XOR, right? So this is what we wanted to achieve. So you got it, and the XOR of this is going to be XOR X, Y, Z, A and B, right? So this one we have already achieved using the first step, right? We just do not know the order, but we are getting the XOR. So these are the 2 steps that are very crucial. I hope you understood. If you did not understand, please go back to the same video and play this part. So once we found the first and second steps, what we're supposed to do is the P of 0 is definitely going to be XOR of all elements and XOR of all elements except 1. Like if you see that XOR of all is going to be X, Y, Z, A, B, and XOR of Y, Z, A, B. So when you perform this operation using the XOR property, two elements XOR is 0, so I'm cancelling it out. Z, Z gone, A gone, B gone. So you'll be finally left with X. This is the first element in our perm. So you're getting the first element as we wanted to, right? I hope the approach is very clear. So let's dry run this using an example. So here I'm taking the same example that is there in the Leetcode. So the first step is to find the XOR of all, which is the perm elements XOR. So we do not know the perm elements, so what are we supposed to do? We are supposed to use the property that is already given in the question, that is finding, the elements are going to be n plus 1 natural numbers. So the n plus 1 natural numbers means 4 plus 1, that are first 5 natural numbers, which is 1 XOR 2. We do not know the relative order, so for XOR we do not need it. So this is the first thing we are supposed to do. And the second thing is find the XOR of all except the first element. So that is, as discussed in the approach, we are supposed to start with this element, leaving the next one, go for this one. Like we are finding the alternate XORs of the encoded array starting from the index 1, that is 5 XOR 6, but we know that 5 is the XOR of 4 and 1, and 6 is XOR of 5, 3, right? So this is, I am just expanding it for better understanding of why we are doing this. So third step is going to be finding the first element of the perm. P is perm. So the formula is XOR of all. So XOR of all except 1. So XOR of all is going to be 1, 2, 3, 4, 5, and XOR 4, 1, 5, 3. So the similar elements get cancelled out. That means they become 0 in the XOR. 1 gone, 3 gone, 4 gone, 5 is also gone. So clearly the first element is 2 in the perm array. So using this we can generate the other elements, right? So P of 1 is equals to, as we have already seen the formula, 0 XOR P of 0. We know that this is 6, right? 6 XOR 2. So it is going to be 4, and P of 2 is going to be in 0, 1, and 1 P of 1. So N1 is 5 XOR 4, so it is 1. So P of 3. So similarly you'll get all the elements. The next element is going to be 5, and the last element is going to be 3. So this way we arrived at what we wanted, that P is equals to 2, 4, 1, 5, 3. I hope the approach is pretty much clear. So let's move to the code, which is in the C++. So this is the C++ code. So initially I'm taking an perm array to store the perm values. We know that the perm size is plus 1 of the size of encoded. So that is this first one, and we arrived this formula, right? Perm I equal to perm I minus 1 XOR encoded I minus 1. So initially I'm the first step, XOR of all. So we are finding XOR all of starting from 1 to perm size, which are the n plus 1 natural numbers you're getting at this step. And next the second step is going to be XOR of all except 1. So I'm starting at the index 1 of the encoded, and I am finding the XOR of all the elements in the alternate positions. So that way we can get XOR except the first element of the perm. This is the second step, right? The third step is going to be the finding the first element, which is XOR of all, and this XOR of all except 1. right? I'm assigning it, and then I'm finding the perm values for the rest of the elements. So this way I found the solution, and at last I'm returning the perm. So let's see if this is running or not. Yeah, yes, it is running. So that is what I wanted to tell, and thank you so much for watching this video. If you like this video, please do share, subscribe, like, comment,